Hello there, my name's Gary Sims and this is Gary Explains. Now the Raspberry Pi Foundation seem to be continuing in their search for some form of validation in this world by bringing out a new product that is nothing to do with the Raspberry Pi as we know it. Of course, recently we had the Raspberry Pi 400, kind of that culmination of that dream to bring back a home computer from the 1980s to the 2020s, and I'm not saying it's a bad machine, it is a good machine and it does fulfill that role. And now the foundation has gone completely the other direction, down to the microcontroller level. So here it is, the Raspberry Pi Pico. It's a very interesting board. There are of course so many microcontroller boards in this world, from Arduino and just so many others, but here it is. They thought they wanted to produce one as well, so let's have a look at it. Let's see how you get it up and running with it and how you use MicroPython on it. So if you want to find out more, please let me explain. Okay, so the traditional Raspberry Pi boards are able to run full operating systems, so you can run Linux on them, you can get a desktop, and you can connect USB and Wi-Fi and Bluetooth, and you get a kind of that full computing experience. And as I said, that's kind of the fulfillment of that is the Raspberry Pi 400 with the built-in keyboard and all that kind of stuff. Now, at the other end of computing, you've got microcontrollers. Now, microcontrollers are different to the processors that you get in the normal Raspberry Pi for a few reasons. The first is they run at a very, very different clock speed. So a Raspberry Pi is 1 gigahertz and upwards. A microcontroller normally runs at 48 megahertz, 133 megahertz, as is the case of the Raspberry Pi Pico, 200 megahertz, that's kind of like the maximum you get. Secondly, there's no virtual memory hardware. That means you can't run an operating system like Linux because there's no way the hardware can do virtual addressing. And of course, because of all that, it also means that it's much, much low power. So that when you turn it on, you can run it from maybe a battery pack or some kind of little cell battery, and it might run for months at a time. I'm sure there'll be some interesting tests about how long a Raspberry Pi Pico can run on different types of battery setups. And the last thing is that when you start it starts up instantaneously. It's not booting up Linux. You're not waiting for the desktop to come up. You're not waiting for moving your mouse till it starts moving and it's all there. It comes up in kind of, just under a second, and the program that's kind of on the flash, that starts running straight away. So it's a very different proposition. Of course, it's still very, very useful for makers and hobbyists and amateurs who want to be able to use hardware and software, Python or C and C++, to control things like stepper motors and read temperature sensors and display drivers, use displays, little character displays, all that kind of stuff. You can do all of that with the Raspberry Pi Pico. And the other thing, of course, is the cost. These only cost $4. So in fact, when I ordered two straight away, because I said, well, might as well have two here I could be using for different projects. Now, it's an interesting question, of course, should you buy a Raspberry Pi Zero, which is $5 without the Wi-Fi, or a Raspberry Pi Pico for $4? Obviously, we're talking just a few dollars for either board. And of course, they are different, as I said. The other one will run Linux, you need an SD card in it, you need to plug in your keyboard and a display, and it runs a full desktop. When you boot it up, it might take a minute or so to boot up. This is a microcontroller, very different, lower speed, lower performance, but boots up almost instantly and starts running the program that you've got here on the memory. Let's take a quick look at the specification. As I said, it runs at 133 megahertz, dual Cortex M0 Plus cores in here, and that's why it's called the RP2040. That chip there is the RP2040, the 2 standing for dual core, the 0 part standing for Cortex M0, in this case M0 Plus. Then the last 2 are about the amount of RAM and the amount of storage. So this has got 264K of RAM, and it's got 2 megabytes of internal storage. There's an LED that's built in so that you can program it to flash pretty simply without having to build any extra circuitry, and of course USB for powering it up, for putting programs on it, flashing it, and also you can get some serial debug information over this as well. Talking of debug, there are also pins for proper hardware debugging, which they tell you how to do, which you can actually do from the Raspberry Pi without having to buy any special debug hardware. So that's a good advantage of using the Raspberry Pi to program and control this. Okay, so what we're going to do is we're going to look at how you get MicroPython. So there's a MicroPython interpreter which you can put on the flash, and then you can put Python programs onto the flash as well, and it will run that Python program all the time. So it kind of boots up into the interpreter, then runs the Python program. A really super easy way to get kind of simple projects up and running. So the first thing you need to do is download Thonny. Now Thonny is a Python integrated development environment that you can get for Windows and for Linux and for Mac OS, and of course you can get it for the Raspberry Pi as well. Now I'm going to be showing you how to do everything on Windows. A lot of the documentation that the Raspberry Pi Foundation have released assumes you're using a Raspberry Pi itself to talk to the Raspberry Pi Pico, and that's a good idea, and they can guarantee that setup because of course they have the Raspberry Pi as theirs and the Raspberry Pi Pico is theirs, and they can show you how to get that working. I'm going to talk mainly about how you do it under Windows, because I think most people who are going to get into this will probably have Windows on their desktop and they will want to use it this way. And of course there are instructions online for how to do it from Linux with the Raspberry Pi, or Linux if you're using a Linux desktop, or even from Mac OS. Now downloading and installing Thonny is pretty simple. You download it from the website, you go through the fairly standard installation procedure, and then the program will be installed. Now once it's installed, you need to fire it up, and you need to go to Run, and then you need to go to Select Interpreter, and then from the drop down list you need to make sure you pick the Raspberry Pi Pico. Now if you're using Thonny 3.3.3 or greater, then it understands what the Raspberry Pi Pico is, and you don't need to do anything. Now there are some plugins if you're using an older version, but my recommendation is you go with the newer version. It understands what this board is, and you just say, yeah, please use that, and it knows everything that it needs to do. So let's take a look at how you get MicroPython running. So to get MicroPython on your Raspberry Pi Pico, you need to go to the Getting Started page. There'll be a link in the description below. You scroll down here. Here you'll see 3 tabs: the board specification, getting started with MicroPython, and also how getting started with C, C++. Today we're looking at MicroPython. If you scroll down to this tab here, there is download the UF2 file. Click on that and download it and save it somewhere where you know on your PC. So it's really easy to get new binaries onto your Pico. What you do is press that boot select button, connect it to the USB, and then it will appear as a USB drive on your computer. You can see here it's appeared for me as drive N. You might have a different drive letter, but the important thing, it says RPi RP2, and you'll see these 2 files in there. You don't need to touch them, but if you look here on my desktop, here is that download of the MicroPython that I had, and all you do is you just drag it over, let go, and that will copy onto the board, and then the board will automatically reboot into MicroPython. It's also worth mentioning that if you don't want to do the whole drag and drop thing from the desktop, if you're inside of Thonny and you've got the right interpreter selected, you can click on the install or update firmware. It will go and get that automatically from the internet for you and allow you to install it. Okay, so we're back inside Thonny, and I've altered the font size and everything so that it's easier to see on the screen. Now, down here at the bottom, you can see it says MicroPython 1.4 Raspberry Pi Pico. So this is actually the Python interpreter running here using the command line that you can use inside of Python. But we're going to write a program, and we're going to start with the very simplest program. Just going to say hello Pico. Okay, simple as that. I'm assuming you know a little bit about Python. I do have a 1 or 2 videos about Python here on this channel if you want to brush up on some of your Python skills. Now, once you've typed in your mega complicated program, here we have this print statement. What you need to do is you need to save it. So you go up here and click on the save icon, and it'll ask you, because Thonny in fact can be used as a desktop, you know, just a normal desktop Python environment. It says, do you want to do it on this computer or on the Raspberry Pi Pico? I'm going to say on the Raspberry Pi Pico. And then it says, please give a file name. Now, if you do main.py, what will happen is whenever you reboot the Pico connected to the power, it'll run that file automatically. So it's the program that will run as soon as it's connected to the power. So that's what we're going to do. We're going to say OK. And there it is now saved on the machine. And if we go up to this little run button here, we press that and it will run it. And as we will see down there, the font is actually smaller there, but it says hello Pico, exactly what it is that we wanted to do. So you could now start writing Python programs here and have the output come out there on the little sort of the display, the little connection they've got to the Pico board. But let's do something, because this is a microcontroller, let's do some controlling of things. So of course, the best thing, the first one, is always to control the LED, and there is a built-in LED on the board. It's connected to GPIO pin, GPIO, general purpose input output, GPIO pin 25. So we're going to write a very small program that can flash that on and off. Very, very simple. 2 lines to start with about importing things from machine. That's one of the libraries provided. Import pin. Pin gives you access to the GPIO pins. Okay, and also we want to import UTime because we want to do a sleep. Make the program go to sleep for a little while. Of course, that's because we're flashing the LED and we want it to flash on and off. So we're going to define a variable called LED, and we're going to say it's connected to a pin, and it's pin 25, and it is what, an input or an output? Well, it's an output pin. So that's the pin object they give you as part of the MicroPython, and it tells you we want to be able to control that pin for output. Now we have a while loop, and we're just going to go around forever and ever. So we say while true, and then what's going to happen? First of all, we're going to turn the LED on. So you say LED value 1, pretty simple. Then we're going to sleep for 1 second. So we can say utime dot sleep 1. So it sleeps for 1 second. Then we say LED value 0, turn the LED off again. This is really, you know, advanced stuff here. And then again, we go back to sleep. And then, of course, it will go around in a loop, turn it back on again, wait another second, and so on and so on. Now, if you just click the run button, it will run the code that's inside of the editor. If you want to make sure the file is actually saved onto the Pico so that it's always there for when you reboot, you do need to hit the save button first and then the run button. And then it will start working. If you're just kind of doing rapid development here, you could just keep running the run button, but you've got to know that the set changes aren't saved actually on the Pico itself. Let's just hit the run button. Now, as we can see, the LED is flashing there on the Pico board. So I have here a little circuit that I've built using a breadboard. I've connected up 2 important things. One is the OLED display, and we'll talk more about that in a minute. And the other is I've connected up an LED with a resistor, and I've connected it to GPIO pin 14. Here's a quick look at the GPIO layout for the Pico. It's freely available on the Raspberry Pi Pico documentation, which you'll find on the Raspberry Pi website. Now what we're going to do is rather than flashing the internal LED, now let's flash that external LED, and we're going to do it a slightly different way. We're going to do it using a timer. So what we do start off with is from machine import pin, as we did before, but also import timer. So what a timer does is it fires off at a certain interval and runs a particular function in your program. It'll do that regularly. Same again, we're going to say LED is equal to pin. This time we're going to go with pin 14, and it is an output. And now we do something slightly different. We say tim is equal to timer. So we're creating a timer object. And now we're going to define a new function, which we're going to call tick. Which will get called every time the timer is run. Okay, and inside the tick, what we're going to do is we want to say we need access to that variable called LED. So we'd say give me global access to that one. And now there's a toggle, which means if it was on, it goes off. If it was off, it goes on. As simple as that. And then the final part of the main program, now we're outside of the function now, we finished that, is you say tim, that's our timer object, init, initialize it please, frequency, okay, well we're going to go with 2.5 times a second, so this isn't the sleep interval, it's how often you want it to happen per second. Mode is equal to timer.periodic, and callback, what function do you want to call every time the timer fires? Well, we want to call tick. So it achieves the same thing. It turns the LED on and off, but it does it by MicroPython running a timer in the background. When that timer is expired, it fires off the tick program, resets the timer automatically, and just keeps doing that every 2.5 seconds. You can have multiple timers running. Very, very useful way of getting things to happen on a regular basis. And now if we run this, we'll be able to see the LED that we've connected up to the system is actually flashing. Now also I would mention the OLED display. Now there are some packages for support for different types of display. The OLED display that I'm using is using the SSD 1306 I2C interface. It's fairly simple. I2C means you only need 4 pins 2 of them for power, and then 2 of them for the I2C. So it's very easy to wire up to the right pins on the Raspberry Pi Pico, and then you just use the right software package to control it. Let's have a quick look at the MicroPython for doing something on the display. Okay, the first step is you need the Python file that is the driver for the SSD 1306, and that is under the Raspberry Pi GitHub repository. I'll leave a link to this precise file in the description below. All you do, let's go to the raw version. You can just quickly see here, it's just this code that they've provided for how you talk to the I2C this device. We don't want to worry about it. We'll just click raw, and we'll just select all of the text in there, and then we'll go over to the Thonny IDE. In the Thonny IDE, you want to paste all that code. Here I've got the big font, as I said earlier, so there we go, there it is there. And we want to save it on the Pico, and we want to call it SD1306. If you haven't got that file, just type in SD1306 down there, and it will save it onto your Pico. Now, the next thing we want to do is start another file here, and this will now be our main.python, and we want to do something with the display. So what I've got here is a very quick program that calculates prime numbers using division by trial by division, doesn't use a sieve or anything like that, and then it writes it out onto display. So what does it do? First of all, so it imports so that we can use the display, sets the size of the display here, 128 by 32, sets up the I2C interface, and then finally actually says, here is the I2C for the OLED. Then you fill it all with zeros to make the text go black. You can add in some text, which I've done here, and then finally you say show to actually do the actual update. You can do things in the background, then when you do show, that's when it actually does it. At the same time, we're going to use our little timer that we've done before, the little timer here that will flash the LED on pin 25. Okay, and that's just going to run in the background. So we're going to be doing multiple things. We're going to be running the timer, flashing the LED, and we're going to be doing the prime stuff. Here is just a simple prime test written in Python. And finally, what we do in the main loop is we say this. We say for the first million numbers, let's test to see if it's prime. If it is prime, then blank out this section here with a 0. 0 means black there. Then write the text, okay, which is basically the prime number, P there, and then show it. So basically every time it finds a prime number, it will update the display and show it. And it's as simple as that. So once you get the I2C library working and the SSD 1306 library working, you just use the text and the fill commands that come as part of the frame buffer frame buffer library. You can see all the documentation for that is available, of course, online, and you just basically write to the display. So let's just save that on there and run it. Okay, that's about it. So there we go, the Raspberry Pi Pico, another product in Raspberry Pi's lineup. I wonder what they'll come up with next. Okay, my name is Gary Sims. This is Gary Explains. I really hope you enjoyed this video. If you did, please do give it a thumbs up. I read lots and lots of comments about people saying they're not getting their videos recommended. So really the best thing to do is to not use YouTube's recommendation algorithm, not rely on that, but subscribe to the channel, click that bell notification icon, and then you will know when I've dropped a new video. Okay, that's it. I'll see you in the next one.